Hello again. So today I want to continue working on the CHIP8 interpreter. The next thing to implement is actually the frame buffer. So we have kind of a basic version of the frame buffer. It's kind of a module that sits on the CPU, and so the CPU can access the frame buffer. But right now we're not actually doing anything with that. The frame buffer is just kind of there. So we basically need to add a step once something's been decoded to actually render whatever is there. I'm not entirely sure how I'm going to do that, but we'll figure it out. Yeah, we'll figure it out. So first thing to do is to go into the CHIP8 emulator here. Since last time, I've actually added a README since last time. You can see here by the first commit, or the most recent commit. So we'll open up Sublime. So if we go to, oops, I did not mean to open a new window. So if we go to frame buffer, so yeah, this is the frame buffer, and then this currently sits on the CPU. I jumped way too far down. Yeah, so this is the frame buffer, and this sits on the CPU. So in main over here, we can actually access it over here. So what I'm thinking about doing, because this is the actual, not debug mode when we're running it. So what I'm thinking about doing is we get the user's input every time. We fetch, decode, and execute the next instruction, and then here we can basically access the CPU in order to render the frame buffer. So on the CPU itself, let's go to the draw. So this is the last thing. This is the last instruction I need to implement here. And actually, I uploaded a earlier video. This is just a quick fix, and I did a shift left here. 40 is the wrong hex value. 40 is 40 is the 7th bit, not the 8th bit. So it wouldn't have been the most significant bit. So that's just a quick fix. And actually, let's make sure, get add CPU C. So that was shift left, right? Yeah. Okay, cool. So quick fix there. Anyways, so we also need a way. I'm using ncurses right now, and everything's in the ncurses box. So what I'll need to do is have a way to draw from ncurses. So ncurses, let's try ncurses color. Linux journal sounds good. Sure, I accept. So this looks kind of what we want, basically, where we want to draw different colors to the screen. The CHIP8 frame buffer, actually it says over here that the, I think it's more towards the top, graphics, 64 by 32-bit display. Each pixel contains only information on whether or not it's on or off. So we're going to have two colors. We're going to have one for off, which is black, and I'm thinking about doing green. This one uses white here. I'm thinking about doing green for kind of like a cool old school feel, like the real terminal feel. So I think I'm going to do green and black. So actually, so ncurses looks like it has something where you can test whether or not colors are activated on the terminal and exit if it's not. And then in curses, you define colors in pairs. Foreground color on a background color. This allows ncurses to set both color attribute at once, which is often what you want to do. To establish a color pair, use init pair to define a foreground and background color and associate it to an index number. What's the index number? Console support 8 basic colors, green, black, that's all I really care about. Okay. And then to make my color pairs easy to remember, my program defines a few symbolic constants. So we can have two different constants of basically, we'll have two different ones of on or off. So the, which one is the foreground? We don't really care about foreground. So we're just actually going to use spaces and set the background color. So I really never care what the foreground is. We'll make it white just for simplicity. So we'll do foreground color white and then green, black, and then, yeah. Okay, so the first thing this thing is doing is it's saying have colors. If have colors is false, then we're going to end and we're going to print the exit. So we don't care about this because there's never colors in the debug mode, but we do care about it in this mode. So why don't we try it here? There's also just a tiny, I'm going to worry about that later. There's a flash in the screen when you first boot it up, and it's because it takes a second because we set the box, but then we don't actually display it. We actually go through all the instruction, the fetch, decode, execute before doing something. So this is if has colors is false, then we're just going to basically do the same thing where we end the window, and then we basically, and then we can, this terminal does not support colors, something like that. Not support the color output for the, colors is fine probably. This terminal does not support colors. Okay. Cool. And now we do these init pairs because you got a foreground, and we'll basically, I'll kind of define some of these. So let's do this actually on the frame buffer. So because it's only going to be used from here, so we're going to define pixel on is 1, and then pixel off we'll say is 0. Can we use a 0 index for this? We'll find out actually. I'd like to do, because that way it's nice of on off. It really doesn't matter because we're using these defines here. I think it'll look better on top. Actually, this doesn't have anything. Well, it has the CPU. We'll try this. So here we set up. So okay, if it's good, then we're gonna do the opposite. I guess it doesn't really need to be an else statement. So then we're gonna say init colors, init pair. Init pair is gonna be pixel off, color white. That comes from the ncurses library, and then color black. Yeah, color black, and then color white for the foreground for the on, and then we're going to do green for the background. So init pair pixel on is color is white, and then color green. And then actually back over in frame buffer, really off should be first. Okay, so we get so we're going to check if the colors are on, and if they are on, or if they're not on, we're going to exit, and then we're also going to init these two colors here. Cool, that is great. Actually, if I think about the frame buffer, it's kind of weird because it's a char, but really, according to the spec, it just holds whether or not it's on or off. It has to at least be a byte. You can't just have I guess if you really wanted to do something, you do like for I really wanted to be space savvy, we could basically break it up and basically have each byte hold 8 frames. That would work because there's, if I actually go to the, if I go to the CHIP8H here, there are 64 for the width and 32. So that means that you'd be able to hold all the pixels in 4 and 8 bytes. That's cool. I'll worry about that some other time if I really want to do that. It seems kind of unnecessary. Cool to think about though. Okay, so this is basically just going to hold a series of 1s and 0s then to see if they're on or off. So we have those. So we have the colors. And this is basically, this I think has more to do with this game that he's making. Draw a map. Here we go. Attribute on, color pair, grass pair. Is that what he called them here? Yeah. Yeah, grass pair. So to set it, he says, oh, have this on. And then draw it, and then turn off the attribute. So it's attribute on to turn on that attribute, and then attribute off to turn it off. So we can actually just let's look at framebuffer.c. I misspelled buffer there. What was I doing here? The frame height, so I'm going through it, and then I'm going through the width of it. And then I'm adding a character. Where am I adding it to? What is add ch here? I don't recall actually. Adds a character with an attribute and then advances the cursor. I think what I should do is basically the frame buffer is just literally a buffer. So this is just going to be something to control the buffer. I think here I just want to make these 0. So it's just going to be null. So if I clear the buffer, I'm just sending everything to 0. And I don't want to add a character. We'll do the drawing a little bit later actually. Or I can probably just pull out the drawing and put it over here. I'm not entirely sure how to do that, or what I want to do really. That's really what I'm not sure of. If I put the, I should just go with a method. Let me really fast look at the CPU one more time. We're going to do the, here's the clear instruction. This clears the buffer, and if we look at the frame buffer, it just sets everything to 0. Great. That's okay, cool. So that's exactly what clearing the buffer is. And then drawing is going to be the more complicated one, but we're going to basically, we're going to draw to the buffer. Let's see if we can actually implement this. I think we could do it from the bottom by doing the instruction first, and then display n byte sprite starting at memory location I at Vx and set Vf equal to the collision. The interpreter reads a byte from memory starting at the address stored in I. These bytes are then displayed in sprites, or as sprites on screen using the coordinates Vx, Vy. Sprites are XORed onto the existing screen. If this causes any pixels to be erased, Vf is set to 1. Otherwise, it's set to 0. If the sprite is positioned so part of it is outside the coordinates of the display, it wraps around the opposite side of the screen. Display n bytes, so n would be the nibble. From location I at the coordinates vx, vy. The interpreter reads the bytes from memory starting at the address stored at I. These bytes are then displayed as sprites on the screen at coordinates vx, vy. They're XORed onto the existing screen. This is the... Okay. So we're going to get the coordinates here. So we'll do... we have Vx, Vy. So we're going to do register Vx is equal to instruction. So those are, we have Vx and Vy here, and then we're going to get the value here. So we'll just, it doesn't matter if we do it as an integer, so we can do I forget what I call it. If I go over here to the, I think it's on the CPU, I've defined this. Yeah, extra operand is what I've called it. I think it's a value. Yeah, could be one of these. And at that point, I think it's a value. Yeah, I made it a value. Okay. So we have the three parts of it. And then we're going to start reading. Oh, and then I need the value I. Or reads bytes from memory starting at the address stored in I. So we need the address of I. Okay. And then coordinates Vx, Vy. These bytes are then displayed as sprites on the screen at coordinates Vx, Vy. So we have Vx, Vy, and now I need to figure out where that'd be put on the frame buffer. I just gotta think about this for a second. So, and then, so the sprite that's going to be drawn is wherever I is pointing to. So that's going to be, and I think I always forget some of my crappy naming. Memory is actually what I've called it. I'm cycling through all the wrong things. Okay. So we're going to be copying whatever's at the address at I, and we're going to start putting it into the frame buffer. So interpreter reads bytes from memory starting at the address stored at I. So we have the address at I, and then they're displayed as sprites on screen at Vx, Vy. And we set Vf if it's a collision. So this means that we need to take this the value at I okay, so then Vx is going to be our row for indexing. So we'll do CPU frame buffer at Vx is going to be the row, or no, I'm sorry, that's not the row, that's the column, and then we're going to times it by Vy because that's going to be the row that we're on. Perfect. Okay, so this is going to be and then it's for however many nibbles. So for, we're just going to call it register J. Okay, so then we have, because we're doing it for however many nibbles. So if you have 4 nibbles and we're saying draw this to 0, coordinates 0, 0, then we're saying starting at the upper leftmost, we're going to basically draw we're going to read from this memory location, draw that, and then we also need to increment I. And we have a local version of it, so we're not actually modifying what's on the CPU. So Vx and Vy aren't actually int values though. So actually we need the value. So we're going to get register on the CPU instruction dest register. And then we're basically going to do the same thing for Y. But this is the source register. Okay, and then we grab I, and then we're saying that for each nibble that we have, we're going to draw on the frame buffer at those coordinates. Yeah, it's the values that are at Vx and Vy. So if Vx has 0 and Y has 0, we're saying start drawing at 0, 0 coordinates. We're going to draw whatever's at this memory location for however many nibbles were passed to the draw command. Perfect. Okay. I think that's exactly what we want there. Great. So now we have something that's basically drawing things to the frame buffer. Now we have this draw buffer function, but I'm not entirely sure if this is where I want this. We're not even actually adding characters, we're just turning them on. And actually, if I do font, font's probably not going to work like that, because all this is controlling is whether or not the all this is controlling is whether or not it's turned on. So we're just reading that into memory. We'll come back to that. If I go back to CHIP8 here, okay, so that's an instruction to basically draw something, and then we're going to let me look at frame buffer C. So I really don't think we actually want to do that because we already are setting everything on the frame buffer, so there's nothing really I don't think we actually need the draw buffer here. I think the draw buffer would actually be better suited on, yeah. So let's go over to frame buffer H. We don't need the draw buffer here. Okay, I can start closing some of these windows. We're gonna be working with that one. Okay, let's make sure this actually still compiles. Has no member frame buffer. What did I call the frame buffer on the CPU? FB. That's why. Sometimes I really don't like Sublime. At least the Vim emulation. It's the best one out there, but some little things get me. Like that. Okay, let's try recompiling here. So, perfect. Let's see what we've changed here. Okay, we'll go through that a little later. All right. So now we have that. Let's go into... We might want the draw function out here. That probably wouldn't be that bad, because then we can just pass the... let's try it here. We'll do draw buffer, takes in a CPU. And so then we're going to, this is where we're basically, because we've already set the pixel on and pixel off stuff. So we can just basically check if it's on, draw it. If it's not, turn it off. So I'm just trying to think, would it be quicker to, because I'm not sure what the cost of doing, I'm not sure what the cost of setting it on or off is. Because, so recall that this basically attribute on turns it on to one color and then turns it off. So I'm not sure what the cost of that actually is. It may be really cheap, in which case it might just be best to walk through the frame buffer once, putting in all of the colors. So it's like, oh, is this on? Then turn it on, write it, and then go to the next one. Is it on? No, so turn it off and write it then and when it's off. But the only thing I'm now worried about is if that's really expensive, because if it is, it might just be best then to do the setup once. So set up for all the on pixels, go through, if they're on, turn them on, and then turn off all the other ones. Well, actually, the off will be the default. Maybe I'm overthinking it. So let's try this. So we'll do attribute on, color pair, which is like a macro, and then pixel on. So we're turning the pixel on, and then this is basically saying, what is MVH line? ncurses MVH line. Maybe I just want the add char. Add char. I think that's just going to be easiest because I'll just write it here, move on. It may not be the most efficient, but I'll worry about efficiency later. I is less than, and if I go to frame buffer h, total frame buffer size. Is that how I've done it? Total frame buffer size, yep. And we'll do add ch. And what does this take? It takes a constant char. So we're going to add that character and then move on. So if the CPU memory at I is equal to 1, and we'll just do that. Otherwise, we just want to, because we want to I'm not, you know what, I'm going to worry about efficiency later. So we'll turn it on and then we'll do attribute off. How does this person use it? And they turn off that color. Else they'll just add ch. Clean that up a little bit. So if it's between those two, W refresh and refresh, and ncurses W refresh. Refreshes curses, windows, and lines. Okay. We actually just want it on the window. I don't think I'll need the refresh beyond that. So let's try rebuilding. That all still works, and then we report invalid. That's nice. That was what I was saying though. Basically, until you do the first thing, it just sits there and doesn't draw anything to the screen. And actually, I like having this closer there. This is something about ncurses I don't quite understand. Let me just try refresh there then. Oh, if you have a smaller window, I think it can work with that then. Nope, because I'm defining a box, I think, and putting it in there. Okay, we'll set that back. And then I think refresh is for all the frames, and then window refresh is just for a specific window. Yep. Okay. At least I fixed that little bug. So I think refresh is for the entire buffer that ncurses uses, and then window refresh is for a specific window that's on ncurses. In this case, since everything I'm using with an ncurses, because I init ncurses, so that's a box, and then I have a specific window that I'm putting in there as well. I think that's how it works. I'm guessing. And if you know better, please correct me. This is like my first actual project with ncurses. Okay. So that's really cool. And I still don't have, so we'll do draw buffer CPU. And then, oh, my draw buffer is clearing everything. Oops. Well, actually, that's probably not a bad thing. I probably don't need the whole window. with a box around it. Let me just try that. Yeah, I really don't need the whole box around it. And then I'll also have to get rid of the invalid input thing, because that really doesn't do anything. I don't really care about those. Okay, so we have the total frame buffer size. We have the total frame buffer that's being drawn to the screen. If we go over here to the CPU, we have this draw function that draws at these coordinates this amount of things from memory. Let's see if we can't draw something more interesting. So if I look at the ROMs here, I made this stupid little add program that was initially just there to test to make sure my add instruction was working. But let me try doing, oops, so we have CHIP8, and then I want to run the ROMs test CH8. I'm still getting this. I also need a way to quit. I'm getting lost in all my windows now. And that's why, it's because I exited out of this. Projects CHIP8. Should probably wrap this up soon. If I do CHIP8 debug ROMs test CH8. And the whole window gets messed up because I'm running it here, but I mean, I don't know if you've noticed, because it's kind of not, it's a little glitchy. I need to work on that. But here actually is the draw instruction. I just need to kind of check in memory there to see and make sure things are working. And that's something I can add to the debugger. So let's do I gotta really come up with a better way. Can I can't remember if I actually set up the make file. Test RAM. Oh, I was using test. Okay. And not my dumb little add program. Okay. Well, I've kind of rambled here because I thought that I was able to... because I thought that I would be able to add to actually get something printed to the screen, but it looks like I have a little bit more work to do. I implemented the draw buffer here for the buffer that's on the CPU. And then we also on the CPU finally fleshed out that instruction for drawing it, which is cool. But now I just need a way to actually write it to the ncurses buffer. Okay. All right. I think that should be enough for today. I'll eventually get to finding out why. Well, right now, actually, I'm clearing everything on the screen. I'll have to think about this a little bit, and then I'll be able to get back and figure out what I'm doing wrong here. But that's going to conclude it for today. So thanks for watching, and I hope I'll be back with a better idea of what to do here. I think this will take some more research. I was kind of just diving into this blindly. I think I made some decent progress on it, but there's definitely more to be done. So yeah, hope you have a good day, and thanks for watching.